Hi everyone. So for today, we will be discussing the second topic for this chapter, which is about relative dating and absolute dating. So again, this is the big idea. Here are the different competencies that hopefully you guys will be able to achieve at the end of this chapter. So, relative dating and absolute dating. So the question is, how did scientists piece together the events that happened millions or billions of years ago, long before humans even existed? So geologists reconstruct the sequence of events from the study of petrology, of stratigraphy, and also of paleontology. So these are the things that they studied on for them to be able to reconstruct the sequence of events by which or the events that happened on Earth. So what is petrology? So petrology is a branch of geology that deals with the origin, composition, structure, and classification of rocks. When we say stratigraphy, this is the study of rock layers or strata and layering or stratification. So paleontology naman, on the other hand, studies the life that existed prior to or sometimes at the start of the Holocene epoch. So the current geologic epoch. So the epoch that we are in right now. It includes the study of fossils to determine how they have evolved and interacted with the environment. So based on the information gathered from the study of rock composition and structure, rock layers and fossils, geologists develop the geologic timescale. So it represents the interval of time occupied by geologic history of Earth, and it provides a meaningful time frame wherein events of the geologic past are arranged. And there are two ways in which scientists piece together the events and measure the geologic time. These are the relative dating, and the other one is the absolute dating, which I will discuss later. So first off, relative dating. So this is wherein the chronological sequence or order of occurrence of events are known without knowing their actual age. So it simply means that event B occurred before event C but after event A. So basically you don't, or the relative dating do not really give off the actual age of a certain event, but it gives you the chronological order, if it happened first, second, or what sequence did it occur. So, the relative order of geologic events can be established by applying the basic principles, namely the principle of original horizontality, the principle of superposition, the principle of cross-cutting relationship, and the principle of inclusion. So these are the different principles underlying the relative dating. So first, what is the principle of original horizontality? So according to this principle, sedimentary rocks are deposited as horizontal or nearly horizontal layers, and any deviation from horizontally indicates that deformation occurs after the deposition. So it's pretty much self-explanatory, as the name itself suggests, original horizontality. So whenever sedimentary rocks are deposited, they confirm or they conform a horizontal position. Second, we have the principle of superposition. So in the sequence of sedimentary rocks, the layers at the bottom of the sequence is oldest and the successively higher levels are successively younger, as shown in this picture. So basically, all you have to remember is that the ones or the layers below are the old ones, and the ones nearer to the surface of the earth are the younger layers. Third, we have the principle of cross-cutting relationship. So geologic features such as faults or igneous intrusion is younger or considered younger than the rocks that they cut across, as shown in this picture. So basically, when you see that there is a layer that cuts across all the other layers, we consider this layer as the youngest layer. And then finally, we have the principle of inclusion. So it says that if rocks or rock fragments are included within another rock layer, the rock fragments must be older than the rock layer they were embedded before any time period can be recognized by its fossil content, as shown in this picture. So basically, all you have to remember is that the ones inside or the one being included is older than the one that includes it. So the one that is embedded within is older, and the one that covers it is younger. So inclusion. Next, we have the principle or the absolute dating. So absolute dating places actual age of rocks and events, as opposed to relative dating, which only tells you which one is older or younger. So the method used is radiometric dating technique based on the decay rate of certain radioactive nuclides within fossils, rocks, and any artifact. So the decay rate is described in terms of half-life. So half-life is the time required for half of the nuclei to undergo a radioactive decay. So I will not be discussing this in details because this will be discussed further in your chemistry subject. So remember that the half-life value is constant. So with the knowledge of the decay rate and the parent to daughter isotope ratio, absolute date may be computed using a simple mathematical formula. And these are the common radioisotopes used to determine geologic materials. So just remember, half-life is the time required for half of the nuclei to undergo radioactive decay. And this is what they use to tell you how old a certain piece of material is, specifically for rocks, fossils, or artifacts. So the most common elements used for absolute dating includes uranium, thorium, potassium, rubidium, and also carbon. So the use of radiometric dating method revealed the following information. So first, the oldest rocks on Earth found in Greenland are 3.7 to 3.8 billion years old. Second, the oldest moon rocks taken by the Apollo mission were found to be 4.4 to 4.5 billion years old. Third, the majority of 70 dated meteorites have ages that range from 4.5 to 4.6 billion years old, and the age of Earth using isotopes of lead is 4.5 billion years old. So radiometric dating is also used in determining the ages of fossils, early man and mineral deposits, recurrence rates of volcanic eruptions and earthquakes, reversals of Earth's magnetic field, and age and duration of geologic events and processes.